Okay, students, today is SohCahToa, trig, basics of trigonometry. Okay, you'll do a lot of this in Algebra 2 and Pre-Calc, Calc. We'll do it possibly at the end of this year as well. SohCahToa is an acronym. The capital letters stand for trig function. S stands for sine, as you see right here. C stands for cosine, right there. And T stands for tangent. And these are only in right triangles, as you see right here. Okay. Sine and cosine and tangent on your calculator are just use the first three letters of each word. So we don't say sin, even though it's spelled sin there. It represents sine, cosine, and tangent. The O, little o stands for the opposite as it shows right here, and H is hypotenuse, and A is adjacent. And we know adjacent means next to, and we know hypotenuse means across from the right angle. The first thing you always want to identify is the hypotenuse every time. Every single time, then you can't mess it up. Adjacent means the side next to the angle you're referring to, and opposite means across the way. We talked about that already when we talked about if we know angle measures, then we know we can order the side lengths based off those angle measures, based off their opposite side. Or if we know the side lengths, we can identify which angle is the greatest to smallest, or smallest to greatest, because the side length corresponds with its opposite angle. That's what created that side. So we've already talked about opposite, adjacent, and hypotenuse prior. But now let's go ahead and look. You should see from the acronym, SohCahToa, that this is where the three equations are summed up. And sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Today we will only focus on the left three, not their reciprocals. So there are three more. Each one has a reciprocal. Theta is always, this is theta right here, Greek letter theta, always is an angle measure. That will be the same thing when you get to Algebra 2 or Pre-Calc. There's also another one that they use for angle measures, and that's called alpha. Looks like that. But we're only going to be dealing with theta in geometry. You might see a theta, an alpha on the DCAS. I don't think so. I think it's always theta, or just tells you the angle itself. And just like we use extra y as a sine lengths. The only thing you can stick next to a trig function, such as sine, cosine, and tangent, is theta. Technically, it can be alpha as well, but we're not going to deal with that. You'll see that more pre-calc a lot more, which is an angle measure, never a side length. It means the same thing, theta and alpha. Also, remember that angle measures are identified with capital letters, A, B, and C, for example. Side lengths are the lowercase letters, such as A, B, and C. We've already seen that recently on worksheets that we've done. So that's all review. You must be able to identify the O, A, and H, opposite, adjacent, and hypotenuse, correctly on your right triangle. H, hypotenuse, is always across from the right angle. O and A may switch depending on where the theta is located. But hypotenuse never changes. That's why we identify that first. Also, remember that the two non-right angles are complementary. Since obviously we've already used up 90 degrees in the right angle, we only have 90 degrees left. Two angles that add to 90 are called complementary angles. So if we call one angle theta, then the other angle must be 90 minus theta. So they add to 90 degrees. 90 minus theta plus that theta equals 90. That's complementary. The only difference between the two is where theta is located. And this switches the O and the A, never the H. Hypotenuse is always the hypotenuse, never anything but the hypotenuse. So, example, if I have triangle ABC here and I put theta down here at angle B, the first thing I identify is the hypotenuse across the right angle. Well, which side is it next to theta? It can't be the H because we've already identified H. Is it the opposite or adjacent? Well, which one it means next to? The adjacent. So it gets the A for it's right next to the theta. Obviously, O means opposite. So O is right there. Now let's say we switch and put theta up here at angle A. Does the hypotenuse ever change? No. You identify that first. It's always across from the right angle. Now which side is next to the theta? the adjacent side, because adjacent always means next to, and O means opposite or across from. Same thing. People prefer across from versus opposite, same thing. Okay, opposite is opposite. Okay. Those sides, we call it side A, B would be the hypotenuse, BC would be the adjacent side, and AC the opposite side. Remember, these are segments. They must have a segment bar over it. People lost points on your last quiz or test because you didn't put segment bars. Whenever it mentions the side length, you have to use segment bars. Without it, you should know from 2 weeks in geometry here that nothing above the letters A, B means the distance from A to B, the most missed one of all. All right, more examples will be on the next page. Here we have sides lengths of 3 and 4. I should automatically recognize that as a 3, 4, 5 Pythagorean triple. Otherwise, I'd have to use Pythagorean theorem. So here's where we get into those who have memorized your Pythagorean triples. So now that I have all three sides filled in, notice it's asking the sign of A for these three right here. A, that means put theta in A. Well, hypotenuse never changes. It's always 5. So it says opposite over hypotenuse. You see the hypotenuse. Both are 5. And the adjacent side is the one next to it. That's the 3. So that's cosine is adjacent over hypotenuse, so 3/5. The sine of A is the opposite. That's the adjacent, so 4/5 for that. And tangent means opposite over adjacent, so over A, which is 4/3. Okay. Now, what I've done next is I've done the reciprocals also. Remember we talked about we want to do the reciprocals? Well, I went ahead and did the reciprocals. So the reciprocal of sine is cosecant. CSC stands for cosecant. That's a C. Cosecant. CSC. So in this case, it is not the first three letters because that's be COS, which just stands for cosine. So CSC is cosecant, and it's just a reciprocal of sine. So reciprocal of opposite over hypotenuse is hypotenuse over opposite. So the reciprocal of 4/5 becomes 5/4. Okay, the next one we have is the reciprocal of cosine. The reciprocal of cosine is called secant. And so it's reciprocal. The reciprocal of A over H would be H over A. So the reciprocal of 3/5 becomes 5/3. And lastly, our last reciprocal is cotangent. Let's bring in a different color here. Blue, we have it. Cotangent. And that one, we can use the first three letters. COT for cotangent. SEC for secant. First three letters work because we haven't used it, but we can't use it for cosecant because that'd be cosine. So again, opposite of or reciprocal of tangent over A is A over O. So the reciprocal of 4/3 is 3/4. They're just reciprocals. Here's your 5 main Pythagorean triples that you should have memorized. If not, memorize them now. It will save you on your homework. Okay, don't forget you can have multiples of these, multiply all of them by 2 or 3 or 4 or 10. Okay, and they all work. All right, let's look at some examples now. Okay, fill in the O, A, and H. The arc is the same as theta. Should have had right there. So here's my theta right here. Well, I know the hypotenuse is always across the right angle. What side is next to the theta? Right there is my A. And obviously across the way or opposite it is O. Okay, so here we have an actual problem. Solve for B, the height right here. Remember, the first thing I do is identify the H. Across the right angle is the hypotenuse. Next to that side is the adjacent side. So there's my A and there's my O right there for opposite. So I'm solving for the O in this case, which is B. So I look at what's given to me. I'm given the hypotenuse and I'm searching for the opposite. So which one has the letter O and H in it? In SohCahToa, right there, O and H. Sine. So I have the sine. Remember, theta represents an angle measure, so that's 35 degrees. Equals the opposite, B, over the hypotenuse, 16. I can always put that over 1, and I just cross multiply. So I get B equals 16 sine 35. Okay, this is called the exact answer because I haven't put in the calculator yet and rounded it. Okay, if it wants the approximate answer, then I plug that in the calculator. 16 sine 35. Now, let me bring this up. Let's go to calculator, graphing calculator. Where did I have it? I already have it up there. We'll do clever financial graphing calculator right there. Okay, remember I just hit start, and the calculator's right here in the middle. Bring it up. Now, by default, when I look at the mode, it's always in radians. So I have to go down and change it to degrees. Move over to degrees, hit enter. Second quit to go back there. And remember, it was 16 sine. I don't even have to hit the times sign. It automatically knows that. Sine of 35. And hit equals. And that's 9.17. If we say we round to the nearest tenth, it'd be 9.2. So 9.2. And did it have units on there? Yes, it did. Centimeters. So B is approximately 9.2 centimeters. Okay. Now don't forget that's a 35-degree side. So this other side, which is 55 degrees, remember it has to add to 90. That means this side, this A side over here has to be longer than 9.2. Okay, because remember you know the shortest angle or smallest angle measure has the smallest side. Okay. So somewhere between 9.2 and 16, because the hypotenuse being 90 degrees, is opposite the 90-degree angle is obviously the largest side, so it can't be larger than 16. So that's an idea. If I was trying to find that one, where I know my answer should be between now 9.2 and 16. Okay, there's that. Okay, and what I was mentioning here is I could also use the 55 degrees. So if I want to use a 55-degree angle, what I'm doing is if I use this 55, now this becomes the A, the adjacent side next to the 55. And so I'd have A over H, which is cosine. So cosine of 55 equals A, or in this case B, lowercase b, that's the adjacent side, over the hypotenuse. So if I type in 16 cosine 55, I should get the exact same answer as 9.2 because I'm solving for the same variable there. So if we go ahead and try that and show that, dang it, what was those numbers again? 16 times cosine 55. 16 cosine 55. Notice the exact same answer, 9.2 approximately. Okay, so I can, if I know 35, I know the other one's complementary, so makes it 55. I can use either angle to solve for the variable they're looking for. I just have to make sure if I use a 55, then the adjacent side is the one next to it right there. So it's going to be A over H, which is cosine. So what this is also showing is that the sine of 35 degrees, we just did that, the sine of 35 degrees equals the cosine of 55 degrees. We just saw that. First one we typed in sine 35. Okay, next we typed in cosine 55 and we got the same answer. Okay, so if you want to even see that, cosine 55, sine 35, notice they're the exact same answer. And that goes along with what we're just saying. Remember, they're both complementary angles. So 35 and 55 add to 90. Okay, so the sine of 1, so the sine of x equals the cosine of 90 minus x. Okay, that's the complement. The sine of 1 equals the complement of the other. Okay, which is what I have down here. Okay. Another one just asks what's the tangent of 24 degrees. So remember, tangent is opposite over adjacent. So opposite 8 over the adjacent x. Okay, and now if I want to solve for x, I would just cross multiply. I get 8 equals x tangent 24. Okay, remember I'm solving for x, so I need to divide by tangent 24 on both sides. divided by tangent 24 on both sides. So now you get x is approximately equal to 8 divided by tangent 24. 8 divided by tangent 24 equals 17.96, which rounds up to 18.0. So x would be about 18.0, as you see right there. The exact answer is 18 over tan 24. Okay, approximate answer. Notice I'm putting an approximate sign. I'm using an approximate. I'm not saying equals because it does not equal 18.0. It equals approximately 18.0. Okay, now if you see a problem where it says solve the right triangle, that means solve for any missing angles and side lengths, all of them. So we get all three angles and all three side lengths. Okay, that's what it means to solve the right triangle. And you're going to do this again in Algebra 2 and Pre-Calc. Okay, now let's say I want to solve for theta right here, angle S first. Well, again, identify the hypotenuse right across there, says hypotenuse, and the 7 is the adjacent side right next to the theta. So which trig function has a and h in it? That's cosine. So I have a cosine of theta equals adjacent 7 over the hypotenuse 23. And that's a over h. Cross multiply, not cross multiply. So I need to get rid of cosine now. The way you get rid of cosine is inverse cosine. They cancel each other out. Whatever I do to one side, I must do to the other side. Okay, so those cancel out, so I get theta equals this exactly, but whenever we're dealing with that, we're usually looking for approximate answers. Putting the calculator around to it. So I do inverse cosine of 7/23. Inverse, how I get inverse is second cosine. You see that? Right above cosine is inverse cosine of 7 divided by 23. Enter, and it's 72.3 degrees. Okay, so it's 72.3 degrees, which is what we have right there. So if one is 72.3 degrees, if angle S is 72.3 degrees, then I do 90 minus 72.3 to get 17.7 degrees for U, which is what I'm showing right here. So we found the two angle measures now. Now we need to find the third side over there. Okay, well, I could use, for example, I could use Pythagorean theorem if I wanted to. Okay, because I have two sides. So I can use Pythagorean theorem as one way of doing it. So I have 7 squared plus b squared equals 23 squared. 49 plus b squared equals 529, if you know your squares, perfect squares. Subtract 49 across. That's 29 plus another 20 would be 480. And take the square root of both sides. And obviously, we'd only deal with the positive one because we can't have a negative length. So b is approximately, well, we could do the exact answer. So that would be 16 times 30, because 16 times 3 is 48. Add on the 0. And then that would be, so this would be exact answer, 4 root 30. Remember, root 30 does not break down because there's no perfect square that goes into 30. Okay? So the exact answer would be 4 root 30. And the only way I'm going to get that is using Pythagorean theorem. If they only asked for an approximate answer, I would not have to use Pythagorean theorem. I could go ahead and use one of the SohCahToas, okay, if I wanted to. So an example of that would be, so I'm looking for, again, where's my, change the color here, I'm using too much. So I'm looking for this right here. Okay, I could use tangent, opposite over adjacent. Remember, this is the O. Over there, opposite. There's my hypotenuse. There's my adjacent. So if I used opposite over adjacent, it would be tangent. That's opposite over adjacent. Opposite over adjacent. So it would be tangent of, and what do we say that angle already was? 72.3 equals the opposite, we're calling it x, over the adjacent 7. So now I cross multiply, I do 7 times tangent of 72.3. 7 tangent 72.3. It's going to be close to our answer. That's 21.9 approximately. So, so x is approximately 21.9. That's using SohCahToa. Well, don't forget the real answer was 4 root 30. So if I type in 4 root 30, 4 root 30, hit enter now. Look at that, 21.9. Look how close those are in answers to one another. So the 4 root 30 was the exact answer. The 7 tangent 72.3. Remember that 72.3 was a rounded answer, rounded up to 72.3. Okay, if it would have kept it out to like the thousandth spot instead of the 10th spot, it would have been even closer to 21.9 than the 21.933 is right now. But now you can see that you can use a calculator and you can use SohCahToa now to get side lengths if you're given an angle measure on one of the sides. If you're given two of the sides, I can use Pythagorean theorem as I did right here. Okay. All right, let me erase this here to get this last problem. This last problem says to solve for A. Remember I told you how you get rid of cosine? It'd be inverse cosine. So A equals inverse cosine of 0.11. Now, that's the exact answer. We want the approximate answer. So we type in, as you see right here, inverse cosine of 0.11, and that's approximately 83.7 degrees. Again, inverse cosine is second cosine, 72.3, no, 0.11. That's what we're doing, 0.11. And you see 83.7 degrees, exactly what I had down for your answer right there. All right, that goes ahead and answers all these questions that are in examples here so you can apply it to your worksheet now. Obviously, you might have to review this and we'll do more problems for practice in class as well.